Hi everyone, this is Mrs. GA, and today we're going to be creating and solving equations. So let's start with a quick warm-up. Go ahead and pause the video and give these two a try, and we'll check your answers in just a few seconds. All right, go ahead and check your answers here. So for part A, we had to use the distributive property, combine like terms, and then you can finish solving. And for part B, we had the problem of having a variable on each side of your equation. So we can fix that by subtracting 5x from each side and then finish solving from there. So today we're going to be modeling real world problems with equations to help us solve. So whenever we're doing a word problem, I like to say that we're going to use our desk. And I know that desk is misspelled, but hopefully it will help you remember these steps. The D in desk stands for define your variable. We're going to need to pick a variable, whether it's X, Y, Z, or whatever letter you want to use in our equation. And it's really important that we actually write out what that variable represents. Then the E stands for make your equation. S stands for solve the equation, and then C stands for write a complete answer. So that would be an answer that has units. So we're going to try to use our desk today as we're solving these word problems. All right, so let's give this first example a try together. Vernon and Ellie are bowling. Vernon's score is twice the difference of Ellie's score in 5. Sorry, I meant to write in twice here, so make sure you add that in. The sum of their scores is 320. Find their scores. So first we need to define a variable. So we need to pick one of their scores and define it as a letter. So since it says Vernon's score is twice the difference of Ellie's score in 5, it would be best for us to define Ellie's score. So let's say E equals Ellie's score. So that's that D in desk. We've defined our variable. So now we need to find a way to make an equation. So one really important thing in the prompt is that the sum of their scores is 320. So sum again tells us to add. So we know that if we added Ellie's score and Vernon's score, it should equal 320. So we already know that Ellie's score, we're defining that as E. So we can say E plus, now we need to find a way to describe Vernon's score. So it says Vernon's score is twice the difference of Ellie's score and 5. So whenever you see twice, it means to multiply by 2. So we're going to do 2 times, and then we're going to find a way to describe the difference of Ellie's score and 5. Difference always tells us to subtract. So we do E for Ellie's score minus 5. And then again, the sum should be 320. So this represents Ellie's score and this represents Vernon's score. Now, all we need to do is solve. So let's distribute here. So E plus 2 times E minus 2 times 5, which is 10, equals 320. Here we can combine like terms. 1E plus 2E is 3E. And now let's just finish solving. And last step, divide both sides by 3. So we get E equals 110. So we know what E represents, so now we need to make sure to give a complete answer. It says find their scores. So we know that Ellie's score is simply whatever E is, so it's 110. But Vernon's score, remember we have to do 2 times E minus 5. So I'm going to box Ellie's score. So for Vernon, again we have to do 2 times E minus 5. That represents his score. So we do 2 times 110 minus 5. So remember, with order of operations, we always simplify inside parentheses first. So 2 times 105, which means that Vernon's score is 210. And there you have it. So again, we used desc. We defined our variable, we made our equation, we solved, and we gave a complete answer. Okay, let's try another one together. So this says a rectangular garden is fenced on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. Find the length and width of the garden. So we need to pick a variable, whether it's the length or the width to define. But first, let's draw a quick picture of what's going on. So here's our rectangular garden. And it says that the garden is 8 feet longer than it is wide. Okay, so let's call the width W. So W equals the width, and then we'll say in feet, so we remember what our units are. And it says the garden is 8 feet longer than it is wide. So that means this distance is 8 feet longer than this distance. So we can call this W plus 8. Now we know that for rectangles, the opposite sides are congruent, so we can label these as well. Now that we have defined our variable, we need to make an equation. So this says the rectangular garden is fenced on all 4 sides, and it's 256 feet of fencing. So that means if we add up all 4 sides, it should equal 256. So that can be our equation. We can do W plus W plus 8 plus W plus W plus 8, that's all 4 sides, equals 256. So here we can combine like terms. We can combine the W's and the 8's. So that leaves us with 4W plus 16 equals 256. And now we just need to finish solving for W. So I'll subtract 16 from both sides. And then divide both sides by 4. So W equals 60. So now we just need to make sure we give a complete answer. They want the length and the width. So currently we have the width. We know that the width is 60 feet. Make sure we have our units. And then we know that the length is going to be whatever the width is plus 8. So that means that our length is 60 plus 8, which is 68 feet. All right, why don't you go ahead and pause the video and see if you can give this one a try on your own, and we can check your answer in a few seconds. Okay, so here it's important that we first define our variables, and I gave you a hint to let X equal the number of stamps for David, since there are 3 people we're describing. So if X is the number of stamps for David, it says Phil has 5 more stamps than David. So if I do X plus 5, that's the number of stamps Phil has. And then it says here that Lynn has 3 times as many as Phil. So if Phil has X plus 5, Lynn has 3 times X plus 5. So now that we've defined our variables and we know how to describe how many stamps each person has, we can use the fact that altogether, meaning the sum, is 100 stamps. So we add up the 3 and it should equal 100. From here it's just a matter of solving, but then be careful, we need to find how many stamps each person has. So David is represented by X, which is 16. Phil is going to have 5 more than that, which is 21. And then Lynn has 3 times however many Phil has, so 63. All right, so let's try another one together. Here, this one says Adriana has a job offer at 2 companies. One company offers a starting salary of $28,000 with a raise of $3,000 each year. The other company offers a starting salary of $36,000 with a raise of $2,000 each year. So you can see the first job starts lower, but they give you a bigger raise each year. The second job starts higher, but they give you a smaller raise each year. In how many years would the salaries at both companies be the same? And what would that salary be? So first, let's define our variable. Since they're asking us in how many years, that's going to help us define our variable. So let's say x equals number of years. Okay, so we're wondering if we can describe an equation, or if we can make an equation that shows when one company's salary is going to equal the other company's salary. So we'll have when company, I'll call it company A, the first company is equal to company B. So for company A, again, it said that the starting salary was $28,000, and then they get a raise of $3,000 each year. So raise would imply addition, and then remember, whenever we see the word each, we're multiplying. So let's translate this into an expression. So again, we have 28,000 with a raise, so plus, and then 3,000 each year. So 3,000 times the number of years, which is X. Now for company B, the starting salary is 36,000. Again, we have a raise telling us to add, and then it says 2,000 each year. So 2,000 times the number of years, X. And then if we solve for X, that will tell us in how many years the salaries will be equal, since we sent them equal to each other. So first, let's make sure all of our variables are on the same side. So I'm going to pick the smaller one and move it to the other side using subtraction. So 28,000 equals, plus 1,000, X equals 36,000. From here, we can subtract 28,000 from each side. So 1,000 X equals 8,000, and then divide both sides by 1,000. So X equals 8, and let's make sure we answer the question. It says, in how many years would the salaries be the same? So we would answer the first part, 8 years. But then they also ask, what would that salary be? So we can actually take this and substitute it either into the expression for company A or company B, because they should be the same. So let's substitute it where it says company A. So here's the original expression that represents the salary for a given number of years. So if we plug in X equals 8, we substitute it, then that will tell us the salary after 8 years. So we do 3,000 times 8. So this would give us a salary of $52,000. So after 8 years, at either location, at either company, the salary would be the same at $52,000. Okay, let's do another example together. This one says one moving company charges $800 plus $16 per hour. Another moving company charges $720 plus $21 per hour. At what number of hours will the charge from each company be the same? So let's start by defining that variable. Since they're asking how many hours, we'll say H equals the number of hours. So they want us to make an equation that would describe when the cost for each company is the same. So again, we'll do an expression that represents how much company A costs, and we'll set it equal to an expression that represents how much company B costs. So company A, it says they charge $800, so that's that flat rate fee no matter what. And then it says plus, so we can do a plus sign, $16 per hour. So remember, the word per tells you to multiply. So we do 16 times the number of hours, which we're calling H. Company B, the second company, charges $720 plus $21 per hour. So we can say 720 plus 21 times H, the number of hours. So now we have our equation, and all we need to do is solve. So I'll start by subtracting 16H from each side. So all of our variables are on the same side of the equation. And then we can subtract 720 from each side. And then last, let's divide both sides by 5. So H equals 16. So now we need to make sure that we're answering the question fully. So it says, at what number of hours will the charge from each company be the same? So that would be our H value. So the first part of our answer is 16 hours. But then they also ask, what is that charge? So again, we're going to need to substitute 16 for H into either expression to help us figure out what the charge is when the company is working for 16 hours. So let's substitute it into the expression for company A, but again, it should be the same for either side. So 800 plus 16 times 16 hours. So this should give us a charge of $1,056. Now, just to double check that our answer is correct, we could also substitute this into the other side of the equation, so the 720 plus 21H, to make sure that we get the same answer. So 21 times the 16 hours. And this, you get the same exact answer, $1,056. So that helps us confirm that our answer is correct. Okay, so at this point, I'm going to ask that you pause the video and try this problem on your own, and we will check your answer in just a few moments. Okay, let's have a look. So first, make sure you define your variables. Since it says how many days will it take, that should be our variable. So D equals number of days, or whatever letter you picked is totally fine. So they want to know when the calories consumed by Ruby and Ziggy will be the same. So we can describe Ruby's calorie intake by saying the 120 calories she started with the increase of 100 calories per day, so times D. And then Ziggy's can be described with the 3,230 calories that she started with, and that will decrease, so minus 190 times D, 190 calories per day. If you solve for D, you should get D equals 7. So that's how many days, and they also ask how many calories will they be consuming. So we're going to take 7 and we can substitute it into either side to see how many calories they're consuming. So here, if you see, I substituted into the side from Ruby, and we get 1,900. And just to double check, I tried it on the side for Ziggy, and I got the same answer, which confirms that our work is correct. All right, so here is our last example that we're going to do together. So this one says, Kim works 4 hours more each day than Jill, and Jack works 2 hours less each day than Jill. Over the course of 2 days, the number of hours Kim works is equal to the difference of 4 times the number of hours Jack works, and the number of hours Jill works. So I know that's a lot in one sentence, but we'll break it down one step at a time. How many hours does it take each person to work in one day? So first we need to pick a variable that describes how much one person works. So Kim works 4 more hours than Jill. Jack works 2 less hours each day than Jill. So I think it'd be a good idea to define X as the number of hours that Jill works. So X equals number of hours, and I'll just say for Jill. So if it says Kim works 4 hours more each day than Jill, we can say X plus 4 would equal the number of hours for Kim. And here it says Jack works 2 hours less than Jill. So that would be X minus 2 would represent the number of hours for Jack. Okay, so then we say over the course of 2 days, the number of hours Kim works is equal to the difference of 4 times the number of hours Jack works and the number of hours Jill works. So first we need to describe a way to show this reflected over 2 days. So essentially, so this is 2 days later, you would take however many hours you work and you would double it. So for Jill, it would be 2x. For Kim, it would be 2 times x plus 4. And for Jack, it would be 2 times x minus 2. So this is how many hours they work over 2 days. It's just double the number of hours they work in one day. It says over the course of 2 days, the number of hours Kim works, so let's start with this part. The number of hours Kim works, so that would be 2 times x plus 4. That's how many hours Kim works in 2 days, is equal to, so we'll do our equal sign, the difference of, so we're going to be subtracting, 4 times, again this is subtracting, 4 times the number of hours Jack works, so that's the first part, so we're going to do 4 times this, 4 times 2 times x minus 2, and the number of hours Jill works. So that's what we're going to subtract. And Jill works 2x hours. So this is the difference of 4 times the number of hours Jack works and the number of hours Jill works. Okay, and now we can solve for x to see how many hours each person works in one day. So first we're going to need to start by distributing. So I can distribute here. 2 times x is 2x. 2 times 4 is 8. Here we can multiply this first to 8 and then we can distribute it. So we'll do 8 times x and 8 times negative 2. So giving us 8x minus 16. And then we still have the minus 2x. Here I see that we can combine like terms because we have 2 variables that are on the same side. So we have 2x plus 8 equals 6x minus 16. Let's move our variables to the same side. So I'll move the smaller one with subtraction. So 4x minus 16. Almost done. Add 16 to each side. 24 equals 4x. And last, we'll divide by 4 to get x equals 6. So again, this is just our x value. Now we need to make sure we're answering the question completely. If x represents the number of hours Jill works, we could say Jill works 6 hours. Kim is always going to work the number of hours that Jill does plus 4. So 6 plus 4 is 10. So Kim works 10 hours. And last, Jack is always going to work Jill's hours minus 2. So Jack works 4 hours. And now we have our complete answer. All right, here's the last problem. This one is a little bit tricky, so take your time, pause the video, and try it on your own. All right, so let's have a look here. So first thing that I did was I found a way to describe everyone's height in terms of x. So I said that x is Jim's height. X plus 14 is Ian's height because it says that Ian is 14 inches taller than Jim. And then Lisa's height can be described as x plus 14 plus 10 because it says Lisa is 10 centimeters taller than Ian. Of course, we could combine those, but that's just to show that we're building off of Ian's height. And then it says every month their height increases by 2 centimeters. So that says in 7 months. So in 7 months, if they're increasing 2 centimeters per month, we can essentially add 14 centimeters to each of their heights. So Jim's will go from x to x plus 14. Ian's will go from x plus 14 to x plus 28. And then Lisa's will go from x plus 24 to x plus 38. So this is their height after 7 months. Okay, and it says in 7 months, the sum, so we're adding, of Ian's and Jim's height, so Ian is x plus 28, Jim is x plus 14, will be, so that's an equal sign, 170 centimeters more than, so plus 170, Lisa's height, which is x plus 38. So there's our equation. So we do have to combine like terms, move our variable, and then finish solving, and you should get x equals 166. However, they're asking how tall is Ian right now. So if you look back here, Ian's current height is x plus 14. So you have to take x, which is 166, add 14, and you get Ian's current height, which is 180 centimeters. Okay, that is all for today's video. Thank you so much for watching.